We are on episode 1, part 2. Still on binary operation, so it makes episode 1, part 2. You are given a simple question you are asked to solve, because at your end you may see it very difficult. At your end you may see it very difficult because of how the operation sign has been defined. Yes, how the operation sign star has been defined with the square root issues. You may find it difficult in handling this, but trust me, it's very easy. It's a matter of getting time. You pay attention to every step. All right. An operation star is defined on the set of raw numbers R by S star blah 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 blah. Find the values of K. You are given this to solve, and you are asked to find the value of K here. Every binary operation question given, I would advise you that when you are handling binary operation question, first of all, the operation sign has been defined per certain numbers. First of all, you put your formula down. This is the formula given, and you are asked to follow the formula here. So you first write your formula down, which is S star Y equal to bracket open root X plus root Y bracket open root X minus root Y. This is the formula you are using in finding K star 3. So this is what you are given, K star 3. And we are expecting that K star 3 should give you -1. Looking at the equation, you have the left hand side and we have the right hand side. With your left hand side, it has formed binary in the sense that the same star is put here. So it means the star you are having here is the same thing you are seeing here. So it means your X is K in this, and your Y is 3. So you are substituting, you are putting in K and 3 here. Meaning wherever you see K, wherever you see X, you are putting K. Wherever you see Y, you are putting in 3. So watch it. I'm considering the left hand side. So with the left hand side, it's going to be root X, and you said your X is K, plus root Y, and you said your Y, your Y is what? 3. Followed by bracket open, you have roots. You said your X given is, wherever we see X, we have to put in K. So this is my K. Minus roots. Wherever we see Y, we have to put in, per the formula, we have to put in 3. Equal to -1. Now you've gotten binomial expansion. I know you can do better here because this is binomial expansion. You are expanding the bracket here. So root K times root K will give you root K all squared. Root K times root K will give you root K all squared. Or if possible, let me do it this way for people to understand. Let me do it this way. You pick root K, then you multiply by the whole of this bracket, which is root K minus root 3. Then you pick your second term, which is plus root 3. Then you multiply the same second term by the second bracket here, which is what? Root K minus root 3. This is how to handle binomial expansion. So now I've gotten K star 3 as this here, equal to -1. All right. So from here, I'll use the first term to multiply the whole of second bracket. This is what I'm getting. And I'm using the second term here. This is the second term plus root 3 to multiply. This is what we were taught way back in JHS, how to do expansion. When 2 terms is multiply another 2 terms, this is how you solve it. From here, we are using the idea of set. Root K times root K is the same as root K, repeating itself twice. Root K times root K, because if you have A times A is the same as A squared. If you have root A times root A is the same as, because root A repeating itself twice. Root A repeating itself twice. So the same principles is what I'm using in handling this. Root K times root K is the same as root K all square minus root K times root 3 will give you what? Root 3K. If you know said better, root K times root 3 will give you root K 3K. When you come here, root 3 times root K is the same as root A times root B. In set, under properties of set, root A times root B is the same as root, then you multiply the root numbers, which is AB. The same principle is what I'm using here. Root 3, this 3 is under the square root, and this K is also under the square root. Then it's going to be root 3K, because both of them are under the square root. We write it as what? Root 3K. And when you come here, root 3 multiplied by another root 3, meaning root 3 repeating itself twice. So you are going to get root 3 all square from the properties of set. And the same number multiplied by the same number, we write it as what? The number all square equal to -1. And from this end, anytime square root meets square, the square root will cancel the square here. You are getting K minus 3 equal to -1. Why? Because this negative root K will cancel this positive root 3K, because they are the same. We have coefficient of 1, we have coefficient of 1 here. So the negative 1 here will cancel the positive 1 here, so that this will go off. So it will be left with K minus, when you come here, this root 2. Square root will cancel square here, and it will be left with -3. And it's what we are seeing here. From here, we have to make K the subject, because we have to find the values of K. So we have to make K the subject here. So K is equal to -1. When you move this -3 to your right, you are getting +3. In that case, our K is 2. We have our K to be 2. Now we've solved for, so find the values of K, and we have our K as 2. For you to understand better, or for you to get what you are doing right, you can put your 2 here. 2 star 3. 2. Now we've gotten our K as 2. We have our K, so 2 star 3. When you substitute these 2 and 3, this 2 here and the 3 here, you are going to get the answer as -1. When you substitute it into this equation, you are getting as -1. So what I did was, we were given this, and this is the binary operation formula, because I'm asked to find K star 3, which is equal to -1. This is the binary. As we're looking at the left hand side, it holds the operation side. I will match this star here with this same star here. So if the same star is happening here, meaning our X is represented by K and our Y here is represented by 3. So meaning I'm to put this K and 3 into this formula. So I'm concentrating on this side, not here, because this one is the same as this. So I'm putting K and 3 into this formula. K and 3. So whenever I see K, I put, whenever I see X, I put in K. Whenever I see Y, I put in 3. So this was what I was doing. K plus our Y is 3. So Y here, bracket close, bracket open, roots. You said whenever I see X, I'm to put, whenever I see X, I'm to put in K. So like that, in that manner. So from here, this is binomial expansion. Binomial expansion. So this root K times root K will give me, so you put here root K times the second bracket, I'm getting this root 3 times the second bracket, the same This is the same as binomial expansion. Binomial expansion. I was doing binomial expansion. Binomial of two, multiplication of two binomials. This is how to expand it. Alright, so k root k. Root k times root k will give you root k squared. Root k here, root k times root 3. Because k is under the square root and 3 is, we'll put them under the square root. From the same steps here, you are applying it here. Root 3 times root k will give you root 3k. And here, pop negate, pop negate. Root 3 times root 3 will give you root 3 all squared. So from here, the square root here will cancel the square here. You are getting k, and this here, with this one will go off. Because this one is negative and this one is positive. So the negative will cancel the positive. At the end of the day, we are getting k minus this 3 here, because here it has cancelled out. So I'm getting this. So finally I had my k as 2. Thank you for watching the part 2 under binary operation. Part 2 under binary operation. You are looking forward to look at the part 3. Thank you.
チャンネル登録してほしい。